Suppose we want to evaluate the definite integral from 0 to pi over 4 of sine of 4t. So in order to evaluate this integral, we're going to need to use integration by substitution. That's because you have an outer function, so the sine function here, and then the inner function 4t. So the typical approach with integration by substitution is to let u equal the inner function, in this case 4t. Then it's important to deal with the differential du, which in this case would be 4 times dt. Well, what we have in the integral here, so we've got integral from 0 to pi over 4. We've got the sine function of 4t, so I'm really just writing the original problem, but I'm going to do some color coding here. And then we've got just dt. So not 4 dt, but just dt. There's two ways to think about this. So you could go back to this equation, divide both sides by 4, maybe write this as 1/4 times du equals dt. So that would be a fair substitution, is to change this dt into 1/4 times du. Change the 4t while we're at it to u. Now, the limits of integration here, if we're going to change variables, it's important to note that these limits of integration, this original integral is in terms of t. So these limits of integration are t values. So you can either change the limits of integration using this equation, or you can just write yourself a little reminder that that these limits of integration are in terms of t, whichever way you prefer. On the next step, I'm going to go ahead and change the limits of integration on this one. So using this substitution and then this equation for the differentials, we've determined that this original problem is equal to sine of u times 1/4 du. So I'm going to put the 1/4 out front. And then we've got sine of u, or the integral of sine of u times du. Now, I'm going to show you something that I may not have shown in class. So this is our conversion equation, u equals 4t. So if we want, we can take these limits of integration and say, okay, when t equals 0, u is equal to 4 times t. So in this case, that'd be 4 times 0, so 0. So our lower limit of integration in terms of u is 0. When t equals pi of 4, then u is equal to 4 times t. So that'll be 4 times pi over 4, so pi. So the upper limit of integration becomes pi. So if you want, you can change your limits of integration so they're written in terms of u. And now we would just take the antiderivative of the sine function. So the function whose derivative is positive sine would be negative cosine of u, because the derivative of cosine is negative sine. And now this is evaluated, I'm going to change this to brackets, from 0 to pi. And these are values for u, so I can substitute those values into this expression. You don't have to change it back to an expression of x if you change your limits of integration. So this becomes 1/4 negative cosine of pi minus negative cosine of 0. I could have factored out the negative, but too late now. So this is 1/4. I'm going to run out of room here. I'm going to back up a little bit. So this is 1/4 times negative cosine of pi is negative 1. Minus the negative, so I'm going to go ahead and make that plus cosine of 0, which is 1. So what do we end up here? This is positive 1 plus 1, so we end up with 2 over 4, which is equal to 1/2. Our final answer in this case is 1/2. And I'll just say one more time, so the reason I didn't have to change this back to an expression of t is because we adjusted the limits of integration on this step here, so they're written as values of u.